Good day and welcome to my final project presentation. My name is Lisirom Lafle, an electrical engineering student at Central University of Technology. Today's session will be divided into two parts: the presentation on how I arrived to the final product and the demonstration of the final product. So, here is my presentation poster. Firstly, I will tell you the problem statement and the aim of this design project. So the problem statement says, during the COVID-19 pandemic, many restaurants couldn't control the rate of how COVID-19 spread. So we came with a solution to control this rate of how COVID could not be spread so much. This is the aim of our product, of our project. It says the aim of the system is to help minimizing the high spread of COVID virus by controlling the temperature and the air quality. This is how the project will work. Okay, firstly, it will detect whether it's a night or is a day mode. If ever is a night mode, the project will have a running fan that ventilates the building the whole night. Okay, so this is the description. What happens in the day mode? On the day mode, the project will allow the user to come to a certain distance, take a temperature. After the user has taken a temperature, the product will sense whether this temperature is the normal body temperature or not. Once it's the normal body temperature, the project opens the door. Welcome. So, what happens inside the building? Once there is a low air quality or the building is not well ventilated, okay, this is what will happen. There will be a gas sensor that will detect the gas or the air quality in the building. Once it's not in the good level or the required amount, the system will sense whether there's wind outside or not. If ever there's not the wind outside, the system will open the windows. But what happens when the weather is not in the good condition? There's a lot of wind. We can't open the windows when there's a lot of wind. That's where the fan will run inside the building to do what? To ventilize the building. So here's the methodology I took. After having our problem, we discussed let me just go the steps on how I arrived to the final product. The planning. After getting the problem statement, I had to plan my design, the solution to the problem. That's one aim of our project. So after having the solution to a project, we sat down and then think what are the components that are going to be needed. After finding the components that are going to be needed, we go to the discussion of a block diagram. Now we check which are the inputs, which are the outputs. The third part is the flowchart. How my project is going to work. Where does it has to start and where does it has to finish? And then the serial code. That's where is the demonstration of how my code will be. And then the other step is the codification. I shared my writing code on Arduino based on the serial code and the flowchart. And the test is almost the last step of the project. I tested everything working on a breadboard to see whether I'm on the right path or what. And then the last step of our methodology is where we design our final product. As you can see, here is the picture of our final product. So, moving along, we had a block diagram this side. We have ultrasonic sensor. These are the components that will be involved in our final product. Temperature sensor, MQ, which is the gas sensor, I've explained it, vibrator sensor to sense the wind, LDR, light intensity, LCD display, servo to open the door or the window, red and green LED to give any indication. Relay module will switch between a fan and a blue LEDs. And then another one, we have a component which is known as the ESP8262 Wi-Fi module. This one will take the temperature of a user and upload it to the ThinkSpeak. This is how we will monitor how effective our program is. Okay, so here's a basic flowchart of how the program will be. It will start detecting the light. If light is not detected, it means it goes back to check, okay, the day mode. Light is not, okay, light is not detected. That means it's a night mode. It goes after night mode, it display, the fan runs all the night. Once again, it will go back and check. Is the light detected? Once the light is detected, it goes to the day mode. Is where it allows the user to reach a certain point and say to the user, okay, take your temperature. Once the temperature is okay, it allows the user to enter the building. So once that is still occurring, it checks inside the building. Is it the gas okay or not? Once it's not okay, it means it opens the windows. Once the gas is okay, it is just keep on running. But it has another way where it checks whether the wind is a bad weather or a good weather outside. When is the good weather, it keeps on open the doors when the gas is not well inside. But when there is a bad weather, it gives us a condition where the fan will run inside the building to make the building well ventilated. So here is just a last picture from our presentation. This is a PCB. It shows how our project will be sketched on a Vero board without using so many wires that I have used inside the project to make it very complicated. So like I said, this is the last, almost the last. Where is our final product? So let me just take you to the final product of our presentation. Thank you. The final product of our project. So we will switch it on from a 5 volt from a USB cable. So as you can see now, right now it says welcome day mode. Because of what? It didn't detect any and it detect that there's a light. So let's check. A day mode, it says it will allow the user to come. The user comes, it says take temperature. The user will take temperature with a temperature sensor and wait up until it says a correct temperature. It says body temperature is 34. It means that is the correct body temperature of the user. The door will open. It says normal body, please enter. The door will close. It goes back to a welcome. It means it allows another user to enter the building. But now, let's say there are so many users inside the building and the air condition is not good. What happens? Let's see. There's a gas detected. Opening window. It opens the window. Up until it closes the window, that means there's no gas detected anymore. But now, let's check. Here we have our vibrator sensor. I'll just do it like this. Let's say there's a wind outside. Yeah? The vibrator sensor will vibrate the wind there. The fan will blow. It indicates that there is a wind detected. That's how our program will work on the day mode. So now, let's check and examine what happens on the night mode when there is no a light detected. This is what happens. The fan keeps on running the whole night as long as there is no light detected. And it says, welcome night mode. Let's check. If ever the user comes at night, will it be able to say no? It does not say the user to take the temperature or anything. And the red LED indicates that there's a building is being closed. As much as in the day night, it indicates that you can't enter. You wait for the green LED to flash so that you know that okay, the temperature is correct. You can now enter. This is how the whole project will work. You see, it goes back again to the day mode. Welcome. The user comes, it says take temperature. The user will take temperature. Again, wait. The green LED flash 33. That means the body temperature is correct. The blue LEDs shows that it's a day mode because as you can see, whenever we detect that okay, right now is a night mode, only red LED flashes. This is the demonstration of the project. Thank you very much.